Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what is the difference between constructor and a method in Java? Let me answer. Constructor and methods look almost similar, but they have few differences. Okay? So what are those differences between the constructors and methods? So I'll write methods here and this side I'll write constructors. They both look same guys, okay? When you write the constructors or methods in Java, right, they almost look same. But what's the difference is methods have return type, whereas constructors don't have any return type, so no return type. And the next difference between methods and constructors is methods can have their own name. You can while creating methods, you can give any name, okay? Can have their own name. But constructors, name should match with the class name, okay? We should give the name of the constructor as class name. It's compulsory, okay? Otherwise, it is not a constructor anymore, okay? So these are the two major differences between constructors and methods. In constructors, unlike methods, we don't have any return type. And coming to constructors, we have to give the name of the constructor as name of the class. But in methods, you can give any name for the methods. So I'm going to practically demonstrate the difference between this differences between these constructors and methods now. Further, I'm going to create a new class. Okay. I'm going to create a new class. And so here I'm going to write something. Okay. Just create some, like some class name. I can give any name for this class. Click on finish. And the Eclipse ID will create a class for me by generating some code here, like a public class name like this. Now inside this class, I can create methods and constructors. Okay. So first I will show you how to create a method, public void sample1. I can give any name. You see the name of the method I'm giving as sample1, sample2, anything you can give. Okay. This is a method, guys. Okay, this is how a method looks like. What about constructor? In method, apart from having its own name, you see class name is different and the method name is different. That's we can give any name for the methods. And second thing is that methods have return type. Okay, if even the method doesn't return anything, also we have to give the return type as void. But coming to constructors, it's not like that, guys. If I have to create a constructor here, I would write like this public and return type won't be there. I should not be writing void here. Okay, or any other return type I cannot write here. And the name of the constructor should be same as the name of the class. So what is the name of this class? Car. So I have to create the constructor like this. Okay. The name of the constructor should match with the name of the class. These are the differences between, okay, a method and a constructor. Remaining everything is same, guys. Okay. Whatever you can do with method, you can do with constructor. Okay. But only the difference between the methods and constructors is constructors won't have return type and okay, constructors won't have return type like void or something, and the name of the constructor should match with the name of the class. I can also derive few more differences, guys. Okay, so in order to call methods, okay, in order to call methods, we don't have to create object. Okay, here constructors will be automatically called when you create an object for it. For example, if I create one more class here, uh, if I create one more class, I'll just name this as demo class, and with main method, I'm going to create. So if I have to call this constructor, if I have to call this constructor and run the code that I have written inside the constructor, what I have to do? Simply, I need to create an object for this class. Okay. New car like this. Okay. New car C is equal to like this. If you say car, etc., what happens? You see in the object creation statements itself, we have this constructor calling statement. Constructors are automatically called when you create an object for them. But if you have to call this method, you see this constructor is calling statement is calling this constructor. But coming to this method, if I have to call this method, I have to use the object reference, guys. I have to explicitly call it. Just by creating an object, method will not be called, guys. I have to simply say c dot sample1. Okay. So one more difference that I can derive from this methods and constructors is automatically called on creating object. Okay. I have to explicitly call using the object reference. Okay. So here object creation itself, the constructor is getting called automatically, where I have to explicitly call it, okay, using the object reference. Okay. So like that, these are few differences, guys. These are few differences. So I'll just note down one more difference here. Constructors will be automatically called on creating an object. Okay. On creating an object, constructors are automatically called. So hope guys you got the answer for this question. That is, what are the differences between constructor and method in Java? So these are the high level major three differences between constructors and Java methods in Java. So with practical demonstration, I have answered this question for you. So that's all for this session. Thank you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what is the scope of local variables in Java? Let me answer. The scope of the local variables in Java is up to the methods in which they are declared or created. We cannot access these local variables outside the method in which they are declared. Okay, only within the method where they are declared we can access the local variables. So the scope of the local variables is up to the method in which they are declared or created in simple terms. Let me practically demonstrate this one for you so that you will be able to understand the answer for this question in a better way. For that, I'll switch to this Eclipse IDE and create a new class. I'll just simply name this class as local variable scope. Okay. I'm just giving some random name. Click on finish. Once I create this class, inside this class, I'm going to create a method, public void sample1 method, I'll say. Okay. And I'll create one more method or two more methods, public void sample2. Then public void sample3, etc., etc. Some sample3 methods I created. In one of the method, let's say in sample1 method, I'll create or declare a variable. So int a is equal to 10, let's say. Okay. Now this variable is a local variable. Okay. Any variable that is declared inside a method is nothing but a local variable, and the scope of this variable, till where you can access this variable, within the method only you can access. For example, if I say system.out.println, if I try to print the value of a, okay, you see no error is coming, it will be printed. That's fine. Okay. Now if I try to access the same variable outside this method, okay, this variable is declared inside the sample1 method, but I'm trying to access this variable outside the method, let's say in sample2 method, system.out.println a. You see I'm getting an error. Okay, I'm getting an error, guys. A cannot be resolved to a variable. I'm kind of error I'm getting. Okay, so this is a problem, guys. This is a problem. You cannot access the local variable. Okay, outside the method in which they are declared. Up to the method only the scope of the variable will be. Okay, so if you want to access a particular variable throughout the class, then the variable should be declared at the class level outside the methods. Okay, this is not a local variable, guys. This is a global variable. Okay, global variable. If you created global variable, the global variable scope is up to the class level, but local variable scope is up to the method only. Okay, in which it is declared or created, but global variable which is declared or created directly under the class can be accessed anywhere. For example, here if I try to access B, you see no error will come. Only for A error is coming, but for B error is not coming. So hope guys you got the answer for this question. The scope of the local variable is up to the method in which it is declared or created. Okay. So unlike global variables, the local variable scope is up to the method in which they are declared or created, but global variables you can access throughout the class. Okay. So with practical demonstration, hope you got the answer for this question. So that's all for this session. Thank you. Bye-bye. Hello all, welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what are the different modifiers we have in Java? In Java, we have several modifiers, and at a high level, we can categorize these modifiers into two types. One is access modifiers, other one are the non-access modifiers. Under access modifiers, we have different modifiers like public, private, protected, and default. And coming to the non-access modifiers, we have static, final, and abstract. So these 7 are the different modifiers we have in Java. That is public, private, protected, default, static, final, abstract. So hope guys, you got the answer for this question. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what are modifiers in Java? Let me answer. Modifiers are Java keywords, and these keywords can be specified before classes, variables, and methods. On specifying these modifier keywords before these classes, variables, and methods, the original behavior of these classes, variables, and methods will get modified or changed. That's why we call them as modifiers. Modifiers are nothing but the Java keywords which can be specified before classes, variables, and methods. On specifying them, the original behavior of these classes, variables, and methods will get modified or changed. That's why we call them as modifiers. Hope you got theoretically what exactly are modifiers now. There are different types of modifiers, and at a high level, these modifiers in Java can be categorized into two categories, that is access modifiers and non-access modifiers. Under access modifiers, we have public, private, protected, and default. And under non-access modifiers category, we have static, final, and abstract modifiers. So these are the different types of modifiers we have in Java. Now let me practically demonstrate, like I'll take one of these many modifiers, and I'll show you how they modify the behavior of these classes, variables, and methods when specified. For example, I'll take this final non-access modifier, and I'll show you how this final non-access modifier when specified before the classes, variables, and methods can change their behavior, original behavior of the classes, variables, and methods. Okay. So for that, I'll switch to this Eclipse IDE, and here I'm going to create a new class under one of these projects. Okay, I'll create a class here. Right click and I'll create a new class. So I cannot demonstrate all the modifiers for you in this as an answer. So if you get such kind of answer, if you demonstrate at least one modifier to support this particular statement, right, that will be all good. Okay. So what I will do simply here is I'll create a new class. I'll just name this class as class A. Finish. Inside this class, the class will get created now, guys, in a while. It's loading. Let's wait. Yeah, class got created. Now here I'll create a variable int a is equal to 10. And I'll create a method public void sample a method. So I'll just simply write down system.out.println inside sample a method. Okay. Save this. Now we have a class, guys. We have a variable and we have a method. Okay. We have class, variable, and method. Right. So originally, if you see here, for example, if I put public here, public class name, which modifier is there before this class? Public is there. Before this variable, public modifier is there. Before this method, public modifier is there. Okay. So if it is like this, and original behavior I'll show, guys. Okay. When it is public modifier mentioned before all these things, what is the original thing? You can see that right already. I'll just create one more class, right click new. One more class. I'll just name this as class B. I'll make this class B a child class, guys. I just created a class B here. I'll just drag this. Class B got created. I'll make this class B extends class A. Now what happens is class B becomes the child class of the class A. Class B becomes the child class of the class A. That's good. Now, what I'll do is, you see, since class B is the child class of the class A, all the members of this parent class A are inherited automatically by the class B, right? Because class B is a child class of class A, all the properties or members of this class A are now part of the class B, that we already know. Now, I'll start, you see, till now, public int A is equal to 10 is there. If I try to update the value of 10 here, A is equal to 20, if I say, am I getting any error here? No, I can change the value of 10, A, right? So this is the original behavior of the, okay, variable, let's say. Okay, variable value can be updated generally. But the moment I provide one of the modifier, that is final modifier, you see I'm getting an error. The final field class A cannot be assigned. That means you can only initialize, but you cannot update the value. Whatever the variable you specify with final modifier with, right? That final keyword or final modifier, right? So the original behavior of the variable will change. Earlier, without final, we are able to update the value of the A. But now, by providing the final here, the value of the variable cannot be updated. You see, I'm getting error. Again, if I remove final from here, I can update. You see, error is gone. So that is one example. Fine. That is one example of how the final, one of the modifiers, that is final modifiers, can change the behavior of a variable in Java. Now the same final modifier, if you provide before a method, what happens? Before providing this final modifier, if I try to override this method in the child class, I can do that, right? Public void sample A. Like this, I can create the same method. Okay, and I'm not getting any error. You see, the child class is overriding, is having the same method as the parent class. So this is called as overriding, right? You can also write annotation if required, at the rate override annotation. I'll not get any error because this method is clearly overriding the method in the parent class. It's same. But the moment I provide final here, the methods which are specified as final in the parent classes, once saved, you see I'm getting an error here. The method on making it final, right? The final methods inside the parent class cannot be overridden by the child class. You cannot override this method anymore. The moment you provide final here, that methods cannot be overridden by the child classes. So I have to remove that. Otherwise, the error will not go. So the original behavior of the method got modified, right? Earlier, when final was not there, you are able to override these methods in the child class. But once you provide a final modifier before this method, that methods we are unable to override in the child classes. You see how the behavior of the methods got changed with one of the modifier in Java. Similarly, if I provide final before the class here, before providing final, guys, before providing final, you see class B can become a child class of the class A. Okay, class A can become parent of any class. Okay, but the moment I provide final before a class and save this, you see, we are getting an error, right? You see, the type class B cannot subclass the final. You cannot inherit, guys, okay? So that means class A cannot be a parent of any other class in Java the moment you provide final here. Again, if I remove this, the error will be gone. So you see the original default behavior of this classes, variables, and methods is getting modified and providing one of the modifiers in Java. So again, if you come back, what are modifiers in Java? You will not now understood, right? You will now understand. Why? Because I explained this with one of the example final. You can try with different modifiers here that are listed here. I cannot demonstrate each and everything for you. But for example, I took final modifier from this list and showed you how by providing this final modifier before the classes, variables, and methods will modify the original behavior of them, right? So modifiers are nothing but Java keywords. When specified before classes, variables, and methods, we will modify their original behavior. Okay. So hope guys, you got the answer for this question with practical demonstration. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what are the different types of variables we have in Java? Let me answer. At a high level, variables in Java can be classified or categorized as local variables and global variables. So what are local variables? The variables that we create inside the methods, and the scope of the variables is up to the methods only, are local variables. And what are global variables? The variables that you create directly under the class and outside the methods, and the scope of these variables is throughout the class, are global variables. So at a high level, the variables in Java can be categorized as local variables and global variables. While local variables are created inside the methods and their scope is or their accessibility is up to the methods only in which they are created, whereas global variables are directly created under the class and outside the methods, and their accessibility is throughout the class. And further, we can divide these global variables into two types. One is static global variables and instance global variables. Instance means object related global variables. Static means class related global variables. Fine. So these are the different types of variables we have in Java. At a high level, variables in Java can be categorized as local, global, and further global variables can be classified as static and instance. Now let me practically demonstrate all this variety of variables for you now in this Eclipse IDE. For that, I'll create a new class. Okay, I'll simply name this class as variables demo, some random name. Click on finish. And inside this class, I'm going to create a method, public void. I'll say sample1 method. And two more methods I'll create just for the sake, public void sample2 method. Then public void sample3 method. Okay, sample3 method. Like this, some variables, some methods I created, some sample methods I created. Now I'm going to create a variable inside this method. For example, if I say int a is equal to 10, this variable is declared or created inside a method. Hence, this variable is known as local variable. Variables which are created inside the methods, okay, are local variables. So what is the scope of this particular local variable? Up to this method only, guys. If you can access inside the method only in which it is created. For example, I'm accessing it here, right? System.out.println a, if I say, you see there, I'm not getting any error and I'm able to access it. Okay, variable a can be accessed within the method. But if I try to access the same variable outside this method, let's say in this method, I would like to access this variable a, system.out.println a, you see, I'm going to get an error. A cannot be resolved to a variable. Why I'm getting this compiler error? Why? Because the variable is, this particular variable is created or declared inside this method. The accessibility or scope of this particular variable is up to this method, starting of the method to the ending of the method, you can use the variable. But outside this method, anywhere if you try to use, you will not be able to access it. Okay, this is a problem. Local variables are local to the methods in which they are created. Whereas if I create a global variable, for example, int b is equal to 20, this variable is a global variable. Okay, we can call this variable as a global variable. Why? Because I created this global variable. Okay, I created this global variable directly under the class. That's why it is a global variable. And what is the scope of this or lifespan or scope or accessibility of this global variable? You can access this global variable throughout the class, guys. Anywhere in the class you can access. For example, you can access this variable in this method, in this method, in this method, because all these methods are part of the same class. Throughout the class, throughout the entire class, you can access this global variable. For example, here if I say system.out.println b, I'm not getting any error. Okay, I can access B. Here also, if I say system.out.println B, I can access. Throughout the class, I can access the global variable, guys. Okay. Now you understood what are local variables, what are global variables, and their scope. Okay, local variables are local to the methods only. Their scope is local to the methods. Whereas global variables, as the name global means, the scope of the variables or accessibility of the variable is up throughout the entire class. Okay, fine. Now these global variables can be further classified. As I mentioned here, these global variables can be further classified as static and instance. Instance means object related. Static means class related. Okay. The common variables, variables having some common values across the objects, right? That variables we generally create as static variables. Remaining all are which change to object are instance variables. Okay. Fine. Let's not go into the details, but at a high level, static variables, we have static variables and instance variables under the global variables. Okay. Fine. So if I put a static keyword here, this will become a static global variable. Okay. Static global variable. And if I say int c is equal to 30, if I am not providing any static keyword here, before you see this is a global variable, this is a global variable because these variables are declared directly under the class outside the method. So they are global variables. But if you mention the static, okay, modifier keyword before this global variable, it becomes a static global variable, whereas this one will become an instance global variable. Okay, instance means object. Okay, another name for instance is object. Object related global variable. Static is for class related, a common variable you can say. Okay, common kind of global variable. Okay, is a static. For example, if you are creating variables related to class, car, let's say. Okay, number of wheels of almost all cars is same, like 4. Such kind of common kind of values can be stored in static global variables. The things like car to car, what will change? Color of the car will change, model of the car will change, price of the car will change, mileage of the car will change. Class to class, if the details are changing, we have to store those kind of values in the object memories. instead of class memories where common memory, class memory, we have to store the common type of values like number of wheels in that car example, whereas the values which keep changing like color, model, price, mileage, etc. can be declared or created under the class as instance global variables, object related global variables, because for every object the values will change. Okay, fine. Anyhow, let's not complicate this, but hope you got the idea, like the variables which are created inside the methods and whose scope is up to that particular method in which they are created are local variables. The variables which are directly created under the class and can be accessed throughout the class are called as global variables. And in that global variables, if you provide static keyword, it will become a static global variable. If you don't provide the static keyword, it will become a instance global variable. So hope guys, with practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, how to access the members of another class in Java. Let me answer. In order to access the members, that is variables and methods of another class in Java, first we have to create an object. For that particular class in which the members are available, the variables and methods are available. For that class, we need to create an object, and using the object reference, we can access these members. That is one way. Or there is another way, guys, where we can make the members of the another class as static. Okay, we can provide the static keyword before the members of another class, like static variable, static method inside that class, and outside the class we can access them by using the class name in which the members are available. Okay, these are the two ways generally we use in Java for accessing the members of another class, guys. First one, by creating an object for the other this class in which the members are available, and by using the object reference, we can access them. Or the other way is that if you don't want to create an object, we can make these members as static, and by using their class name, we can access them outside the class. Okay, so let me practically demonstrate this one for you so that you will be able to understand the answer for this question in a better way. That is how to access the members of another class in Java. Any of these ways we can follow. I'll show one by one way. Okay. First way, I'll create a class. Okay. I'll just name this class as, sample A class. Sample A, just giving some random name. Sample A is the name of the class I'm giving. Click on finish. And inside this, I'll create a variable. Okay, so int a is a variable, and I'll create a method, public void method a is a method name. Okay, I'll just create a print statement here, system.out, just for sample. Inside method a, like this. Okay, a variable and a method. Save this, class, variable, and a method. Fine, all good. Okay, now I'll create another class, say demo class, with main method, or I'll just say demo A. Click on finish. So fine, another class I created. So now from another class, as you can see here, as the question speaks here, the same thing, right? How to access the members of another class in Java. Here another class is nothing but sample A class. Sample A class has this variable and method that I want to access outside this class. Okay. So in the demo class, I would like to access the members of another class. That is this variable and method I would like to access here. How to access? First way is by creating an object for this class and using the object reference, we can access the variable and method of this class. That is the first way, right? Let's try that out. New, how to create an object using the new keyword, sample A. Okay. And SA is equal to, and here I'll say sample A. I'll just simply say sample A. SA dot, you say I can access the variable of this particular another class. Okay, in this class I'm accessing the variable and method of another class by creating an object and using the object reference. SA is equal to 10. I can access. Similarly, if I want to call this method, let's say okay, or by accessing this method outside this class. I already have created the object for this class, and by simply writing sa dot method A. This is the one way, okay? By creating an object for this particular class and using the object reference of the class, we can access the members of the another class. That is the one way, okay? Or there's another way, okay? What is another way? If I don't want to create an object reference and still want to access this variable and method, okay? If I don't want to create an object reference, what we can do is we can make this variable as static and this method also as static, okay? Now, once I make them static, they belong to the class memory. Okay. So I don't have to create an object and using object reference, I don't have to access this variable and method. Since they are static type now, I can simply access them using the class sample A dot, you see, A direct with help of class name sample A dot static, because now it's static. Earlier it was not static, is equal to 10. This is one way. And if I have to call this method by accessing sample A dot method A. That's it. Done, guys. Okay, that's it done. Save this. Sample A dot A is equal to 10, sample A dot method A. Access. Either by creating an object, by creating an object is one way, and using the object reference, we can access the variable and method if they are not static. This variable and method are not static, then that is one way. Or we can make this variable and the method inside this another class static, and by using the class name, we can access. So these are the two ways, okay? How to access the members of another class in Java. These are the two ways, by creating an object or by making those members in the other class static, and by using the class name, we can access them, okay? So with practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I am going to answer one of the Java interview questions. That is overloading possible in inheritance? Let me answer. The answer is yes. Overloading is possible in inheritance. Let's say there is a parent class and there is a child class for that particular parent class. Now, in the child class, we have some methods which are having the same name as the methods in the parent class. Okay. The methods in the child class have the same name as the methods in the parent class, but the child class methods have different number of parameters and different type of parameters. Then we can say that the methods having the same name as the parent class methods in the child class are overloading the methods in the parent class. Okay. So overloading is possible in inheritance, guys. These overloaded methods can exist in the child class, okay, by having the same name as the parent class methods, but differ in the number of parameters and type of parameters in the child class, okay. So let me practically demonstrate this one for you so that you will be able to understand the answer for this question in a better way, that overloading is possible in inheritance, okay. So I'll switch to this Eclipse IDE and create a new class. I'll just name this class as class A. Okay. And here in this class, I'll create a method, let's say public void, let's say sample A or sample. Otherwise, the name of the method is sample. System.out.println inside sample method of class A. Okay, like this, I'll create a method. Now I'll create one more class. I'll just name this class as class B. Now I'll make this class B a child class of class A. So how? Extends, I'll write extends class A. Now class B is a child class of class A, right? Fine, that's also done. Now in the class B, I'll create the method having the same name as the method in the class A. The method in the class A has a sample as the name. I'll create the same. I'll create the method having the same name, like sample, public void sample. Okay. Now, this method in the child class is said to override the method in the parent class. But what I will do is, here I'll give one parameter. Here, the method in the parent class has 0 number of parameters. Though the method in the child class has the same name, it doesn't have 0 number of parameters. It has one parameter, which is different from the parent class method. Even though the name is matching, now this method in the child class is said to overload this method in the parent class. Earlier, without the parameter, this method was overriding the method in the parent class. But now, this method in the child class has different number of parameters, because of which this method in the child class is said to overload the method in the parent class. Okay. Similarly, I can create any number of overloaded methods. The method having the same name as the parent class, but which differ in the number of parameters or type of parameters, whatever it is. I'll just create int a comma double b. Okay, the number of parameters, the type of parameters, because of which the methods in the child class are said to overload the methods in the parent class. So this proves that overloading is possible in inheritance, where the child class methods can overload the methods in the parent class. Overloading of methods is not only possible in a single class. Okay, in a single class, there may be multiple methods having the same name, but if they differ in the number of parameters and type of parameters, we generally say that there are overloaded methods in the same class. But in inheritance, where there is a parent class and child class, can the child class can have the overloaded methods? Okay, of the parent class? Yes, that is possible. When the child class methods have the same name as a parent class, but child class methods differ in the number of parameters or type of parameters. Hence, overloading is possible in inheritance. So with practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what will happen when we specify final modifier before a constructor in Java? Let me answer. When we specify the final modifier before a constructor in Java, we are going to get a compiler error. Okay, this is the answer for this question, guys. We are going to get a compiler error if we specify final modifier before a constructor in Java. But why we get the compiler error? Also, we have to answer as part of this question. Just by specifying that we get a compiler error doesn't make sense, right? The answer is very simple, okay? If you get this kind of question in the interviews, apart from mentioning that the compiler error will come when we specify final modifier before a constructor in Java, we also have to mention the reasons behind that, okay, as an answer for this question. So what are the reasons? In order to understand the reasons, first, we'll understand the final modifier. So in Java, when you provide final modifier before a method, okay, not a constructor, I'm not saying about constructor. If you specify the final modifier before a method, that method cannot be overridden. What does it mean? I'll explain that first practically. So if you specify the final modifier before a method, that method cannot be overridden. So I'll create a new class, let's say class A. Okay, you'll understand practically, guys. Okay, so rather than I explain all the theory, right? Let me explain in a practical way. So you'll be able to understand this concept in a better way. And this class has a method, public void sample method. Okay, sample method. Now here I'll simply write down system.out.println inside sample method of class A. Like this, I'll write a statement. That's okay. Now I'm going to create one more class. I'll just name this as class B randomly. And the class B has been created. I'll just drag this so that you can see both class A and class B side by side. Now I'll make this class B a child class of class A. How? Using the extends keyword, extends class A, like this. Okay, I'll make the class B a child class of the class A. Once I make this class B a child class of the class A, now and create, okay, this class has become the child class of parent class A. Now in the child class, I'll create the same method, that is public void sample. I create the same method with the same number of parameters and same type of parameters matching with the parent class method with the same name and all. Then this method in the child class is said to override this method in the parent class. So this method in the child class is said to override this method in the parent class. Fine. So I can also optionally write @ override annotation, right? I can also write override annotation. So we have this method in the child class, which is overriding the method in the parent class. Overriding is possible now, right? But before this method, if I provide the final modifier, what happens? This method in the parent class cannot be overridden by child class. Okay? The method in the parent class no more can be overridden by the child class methods because we have used final modifier before the method. This is the concept of the final, guys. Okay? Final modifier, what it does to a method, when you specify this final modifier before a method, that method cannot be overridden by the child class methods. You see, error is coming. Cannot override the final method from class A. This is what happens. That we know. But what happens if I provide the final modifier before a constructor for methods? It's very clear that we cannot override the methods. But if I try the same thing with constructor public class A like this, okay? Public class A, the name of the constructor should match with the name of the class, okay? If you're creating a constructor in the parent class, the name of the constructor should match with the name of the class and the constructor will not have any return type, okay? And if I specify the final modifier before this constructor, I am going to get a compiler error, which is the answer for this question. Okay, what will happen when we specify final modifier before a constructor in Java? Compiler error will come. As you can see clearly, when I mention the final modifier before a constructor, for the constructor, I am getting illegal modifier kind of compiler error. Okay, why? Because what is the reason why constructors cannot have this final modifier specified? Why the compiler of Java is giving the compiler error for such kind of constructors? Because there is no possibility for the constructors to get overridden. Can I create a constructor in the child class having the same name of this constructor? Not possible because public, the constructor should have the same name as the class name. So here class B will be the constructor name. Is there any possibility that I can duplicate this constructor in the child class? Not possible, right? The name of the constructor in the parent class will have its own class name, whereas the name of the constructor in the child class will have its own class name. But is there any possibility for this constructor in the child class to override this constructor? There's no possibility because the name of this constructor will be different and the name of this constructor will be different. Because the names of the constructor should match with the names of the class in which they are created. There is no possibility that a duplicate constructor can be created in the child class for the constructor in the parent class. Because of this reason. So is there any need to provide final modifier? Is there any possibility of constructor getting overridden? Because the names of the constructors cannot match here. There's no possibility because child class can have its own constructor name and parent class will have its own constructor name. Okay, there is no possibility of overriding in constructors. Hence, final is not suitable for constructors and hence Java will give you compiler error if you specify final modifier before a constructor. So final modifier is only suitable for methods, guys, and it will stop the methods from getting overridden in the child classes. But if you try to specify the final modifier for the constructors, okay, in the parent class, anyhow, there is no possibility of the constructors getting overridden whether you provide final modifier or not in Java because the constructors in the parent class will have a different name, constructor in the child class will have a different name. If they are having different names, there is no possibility of overriding. Hence, there is no reason or no need of providing final modifier for the constructor. Hence, Java will give you the compiler error. Okay. So hope guys you got the answer for this question. What will happen when we specify final modifier before a constructor? It will give compiler error because constructors cannot be overridden in Java. And as the methods can be overridden, and if you want to stop the methods from overriding, you can mention final modifier before a method that should not be overridden in child classes, but constructors anyhow cannot be overridden as the name of the constructors need to match with the name of the classes in which they are created. So there is no possibility of overriding possibility with constructors. Hence, there is no use of specifying final modifier before a constructor. Hence, Java will give you the compiler error. So with practical demonstration, I have answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, can private variables and private methods can be inherited by child classes? The answer is no. Private variables and private methods are private to the classes in which they are created. They cannot be accessed outside the class in which they are created. Neither they can be inherited by the child classes also. The private variables and methods can only be accessed within the class in which they are created. And if you try to access them outside the class, or if you try to inherit them by their child classes, which won't be possible, guys. So I'm going to prove you that with practical demonstration in this session, so that you will be able to understand the answer for this question in a better way. Further, I'll switch to this Eclipse IDE, and here I'm going to create a new class. I'll just name this class as class P. And in this class P, I'm going to create some private members, that is private variable and method, private int a is equal to 10. And similarly, I'll create a method, private void sample P. Okay. So here I'll just write a print statement for sampleness inside sample P method. Okay, done. So I created a class, and in that class, I created this private variable and private method. This private variable and private method can only be accessed within this class, guys. Okay, can only access the private variables and methods in this class, and outside this class, they cannot be accessed because these private variables and methods are private to this class only. So if you want to access them inside this class, probably provide, I'll create one more method sample, and if you try to access this variable and method inside this class, then okay, because they are private variables and methods, I can access them. You see, I'm not getting an error when I'm trying to access the private variable inside the same class. Similarly, I can call the method also, sample P method also I can call without any error. You see, private stuff is private only to the class in which it is created, and you cannot access this private stuff outside the class, right? But within the class, I can access the private variables and methods that you already know. What if I try to create a child class for this class P, and is there any possibility where these private members of this class can be inherited by the child class? The answer is still no. Okay, I'll prove you that. I'll create a new class, that is class C for random. Randomly, I'm creating the class. Let's say class child class kind of thing. And now I'll make this class C. Anyhow, we cannot access this private variables and methods outside the class, guys. If you try to do so, okay? No matter you create an object or using the object reference, if you try to access this private variables and methods from this class, it won't be possible outside the class. But you may be thinking that maybe I'll create a child class and make the child class, this particular child class inherit these properties. Is that possible? There is a doubt, right? That won't be possible at all, okay? I'll make this class C a child class of class P. Okay, I'm making this class C a child class of the class P using the extends keyword. Now I'll create a method, public void sample C, I'll say otherwise. And in this, I'll try to see whether these private variables and private methods of this parent class are inherited by the child class. If they are inherited, I can directly access system.out.println A if I have to say. And if I should not get the error, guys, okay? So if this variable is really, private variable is really inherited by the child class, I should not be getting the error here for this A. Class P.A is not visible, it is saying, okay? It's not visible because it's private, you cannot inherit that. And also you cannot call this method, sample P method here, you cannot call. Inheritance is not happening, guys. These private variables and methods of the parent class are not inherited by the child class because they can be accessed only within the class. They are private to this class. They cannot be accessed outside the class. So inheritance is also not possible. If I try to access the private variable and private method from the child class, you see I'm getting errors. That means that inheritance is not possible. Private variables and private methods cannot be inherited by the child classes. So the answer is no. Can means no. It's not possible to inherit the private variables and private methods by the child classes. With practical demonstration, I have answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, can we override a method which doesn't exist in parent class? The answer is no. Okay, if there is no method in the parent class, how can you override such kind of method in the child class? In general terms, what is overriding? Overriding means, let's say there is a parent class, there is a child class. And in the child class, if you create a method which is a duplicate of the method in the parent class, matching with the same name and all, then the child class method is said to override the method in the parent class. But in this question, they're asking us, can we override a method which doesn't exist in the parent class? Is it possible? No. But if I try to forcibly do so, that means, you see, in child class, I'm creating a method which is not there in the parent class, but above that child class method, I will provide an annotation like @override. Then what happens? I'm trying to forcibly override a method which doesn't exist in the parent class. In such kind of situations, what happens is a question. You will get a compiler error. Okay. If you try to override a method which doesn't exist in the parent class, then the child class, you will get a compiler error for that annotation that you provided, like @override annotation before that method that you are trying to forcibly override. So let me practically demonstrate this one for you so that you will be able to understand the answer for this question in a better way. For that, I'll switch to this Eclipse IDE and create a class. I'll just say class P, which is a parent class. And in this parent class, I'm not going to create any method. Okay. As you can see, there is no method in the parent class. Now I'm going to create one more class, class C. And let's say this is a child. I'm going to make this class C as a child class by using extends keyword and all. Extends class P. Okay. Now class C is a child class of the class P. Now in such kind of situations, I'm going to create a method which is not there in the parent class, public void sample. Okay. Public void sample. Now, is this method overriding this method in the parent class? There's no method in the parent class. So this method is a method which belongs to the child class only. But if I try to forcibly provide @override annotation on the top of this method, even though this method is not overriding any method in the parent class, but still, if I try to write the @override annotation, you're trying to forcibly make this method override some method which doesn't exist in the parent class. Java compiler will give you an error saying that this method sample, which you are saying that as overriding some method in the parent class, okay, must implement, okay, the class C must override or implement a super type method. There is no method that exists in the parent class with the same name, okay. For example, if I create the same method in the parent class, then it's fine. Then the error will be gone. Why? Because you see, we have the method having the same name in the parent class and the child class method is really overriding. So you see, compiler has removed the error. There is no compiler error now because this method is really overriding the method in the parent class. But if this method doesn't exist, then if I am still providing @override annotation and forcibly trying to make this method an overridden method of some method which doesn't exist in the parent class, then we are going to get a compiler error. So the answer is no, guys. Can we override a method which doesn't exist in the parent class? The answer is no. And if you try to forcibly do so by using the @override annotation, you are going to get a compiler error. So hope, guys, you got the answer for this question with practical demonstration in this session. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, can we specify private access modifier before a class in Java? The answer is no. Before a class in Java, if you try to specify the private access modifier, then you are going to get a compiler error saying illegal modifier and private access modifier is not allowed to be specified before a class. Okay. So let me first practically demonstrate to you what will happen when you specify private access modifier before a class in Java. You're going to get a compiler error saying illegal modifier that I'll show you. After that, I'll explain you the reason why Java will not allow you to specify the private access modifier before a class in Java. Okay. First, I'll go to this Eclipse ID and create a new class. I'll just name this class as sample class. Okay. So the code has been auto-generated by this Eclipse ID editor when I'm creating this Java class. Sample is the name of the class and class is a keyword which is actually creating this class. And here, by default, we have this public access modifier. And if I replace this public access modifier with private, I'm going to get a compiler error, guys. Okay. So when public is there, you see no error. But when I make it or replace this public with private, immediately I'm going to get an error here, compiler error saying illegal modifier. Okay, compiler error saying illegal modifier. You cannot, you cannot specify private access modifier before a class in Java. And if you do so, you're going to get a compiler error saying illegal modifier. So what is the reason why class cannot be of private type? Okay. So the reason I am going to explain, guys, if Java allows you to, okay, so Java doesn't allow us to specify the private access modifier before a class, right? Why Java is not allowing and is giving a compiler error if someone specifies private access modifier before a class? The reason behind that is if you make the class itself as private, no one can access anything from that class. The class will become isolated. If Java does so, the class becomes isolated from remaining programs in the project, and there is no use of creating the class itself. Okay? The class itself is private. Who is going to use the class? So hence, we can specify private access modifier before a variable and methods inside the class, but for the class itself, if you make it private, then what is the use of the class? There's no use of the class. No one can access the class outside, right? If the class cannot be accessed outside, then what is the use of creating the class? The class will become completely isolated if Java allows so. Hence, Java doesn't allow us to specify private access modifier. Rather, Java allows us to specify the private access modifier for the variables and methods inside the class, but class cannot itself be private. Okay? If it makes it private, if it allows us to write the private access modifier, then there is no use of creating such kind of classes in Java. So hope you got the idea and the reason why Java doesn't allow us to specify the private access modifier before a class. Okay. And what will happen if you do so? If you do so, you're going to get a compiler error saying illegal modifier. So with practical demonstration and with the reasoning behind why Java doesn't allow us to specify private access modifier before a class, I've successfully, I feel that I have answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all, welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what is meant by instance in Java? Let me answer. Instance is an another name for object in Java. Okay, you can either call the object as instance or instance as object. So what is instance in Java? In simple words, instance is nothing but object. So instance is equal to object in Java. Okay. So we can say creating an object for a class, or we can say creating an instance for a class. Both are same, guys. Instance and object, both are same. Creating an object for a class, creating an instance for a class. Sometimes we only use the word instance. Sometimes we only use the word object. For example, creating an object. Most of the times, when you are creating an object for the class, you will say creating an object. We don't actually say creating an instance for the class, most of the cases. Okay. We can say so, but still, okay, as per the notation, like how the people developers are there, they keep using the word like creating an object for the class. But coming to the variables and methods, we often call them as, instance variables, instance methods. But object variables, object methods, very less people may call, but I didn't see someone calling variables and methods as object variables and object methods. Rather, all the times I've seen people calling this variables and methods created under the class without the static keyword as instance variables and instance methods. Okay. So the terminology, guys, this is just the terminology. Instance is another terminology or word or name that we use in place of object. Okay, in different circumstances while writing the Java program. In some cases, we use object as a word, and in some cases, we use instance as a word. Okay. So I'll just demonstrate something for you, practical demonstration I'll do in some situations where we use object as a notation while speaking and where we use instance as a kind of name while using, okay, in place of the object. Both are same though. So fine, I'll just do one thing. I'll just delete or make this class, okay? So fine, there is a class, let's say public class name, or I'll do one thing. I'll just create one more class. So I'll just create another class, example class, okay? So just click on the class got created. Inside this class, I'll create a variable, some variables and methods. Okay. Int a is equal to 10. And I'll say static int b is equal to 20. Okay. Static b is equal to 20. And then I'll create a method, public void sample a method. Okay. Or sample one method otherwise. Sample one method. Okay. And I'll create some print statement inside sample one method. Okay, I'll create one more method. Let's say this time I'll just create a static method, public static void sample two. Okay, intentionally I'm creating some variables and methods here. Here I'll write down. Here I'll write down inside sample two method, like this I'll write down. Okay, two variables and two methods. Okay, so in this, okay, in this particular variables here are the global variables. These variables are created directly under the class, but these are both are global variables. Okay, A is a global variable and B is a global variable, but there is a small difference between these global variables. One of the global variable which is not specified with static keyword is an instance variable. Okay, it's an instance variable or instance global variable you can call. Whereas a variable which is also a global variable but specified with static keyword is a static variable. It is a static variable. So what's the difference between these two are global variables, but one is an instance variable, another one is a static variable. So the thing is, when you say instance means the value of this particular variable will be stored in which memory? Instance memory. Instance means object memory. So we generally don't say this as object variable, rather we'll say instance variable. So instance means object, guys. In other words, instance is object. So the value of this particular variable will be stored in the object's memory. Okay, object memory of this particular class. Whatever the object you are going to create for this class, right? In that object's memory, this value of this variable will get stored. Whereas this variable, which is also a global variable, when mentioned with static keyword, becomes a static global variable. And the value of this particular variable will be stored in the class memory. Whatever the class in which you are creating this variable as static, right? The class will be allocated some memory. In that memory of the class, the value of this variable will be stored. Okay, so this is not an instance variable, it is a static variable because it's a non-object oriented type. Okay, so the not non-object, it's a not an instance variable kind of. Okay, it's nothing related to object kind of thing. Okay, so it belongs to the class memory, it belongs to the object memory kind of stuff. Fine. Coming to these two methods, this method doesn't have static keyword. So this program will be stored in which memory? Again, object memory. Okay, we generally call this method as instance method. Okay, instance is the word we are using here. Instance is another word we are using for object. Instead of saying object memory, we are saying instance memory. Okay, most of the people will say instance variable and instance method. Okay, whereas this method has a static keyword and it belongs to the class memory. Okay, fine. Now I'll create one more class. I'll just name this class as demo class and with main method and all. Now in this class, if I have to create an object for this example class, let's say for this example class, in order to access the members of this example class, if I want to create an object here, okay, how I have to create using the new keyword, I have to create an object example class, new example class I have to say, okay, EC is equal to, I'll simply say example class. This statement is called as object creation statement. Okay, here we are creating an object for example class. Here, most of the cases, developers will not say that we are creating an instance for the class, even though that is also right. But even though instance is another word for object, in some situations we use the instance word naming, okay, or terminology or convention. Whereas in some cases we use the object convention. Here you see, created an object for the example class we say, but not created an instance for the example class. Okay, as per the naming, we can say so. It's not wrong, but most of the cases we say create an object for the example class. Okay, this will say as instance variable instead of object variable. This will say as instance method instead of object method. Okay, like that. Some cases we call it as instance, some cases we'll call it as object. So that's what is the difference, guys. Okay, so what is meant by instance in Java? Hope you got a clear clarity on instance means object. In some cases in Java programming, instead of saying object, we call it as instance, like instance variable and instance method. In some cases, instead of saying instance, we call it as an object, like creating an object for the class, etc., etc. So sometimes object, sometimes instant. Both are same though. Okay. So with practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, can we create object for abstract classes in Java? The answer is no. We cannot create objects for abstract classes in Java. If we try to do so, we are going to get a compiler error. Okay. So let me practically demonstrate this one for you. So I'll switch to this Eclipse IDE and create a sample class. Okay. I'll just create a class. I'll just name this as class A, let's say. Okay. Some random name I am giving. Let's say class A, I'm just giving. Click on finish. Inside this class, I'm going to create some methods. Okay. Some variables and methods, if you want, you can create. Let's say int a is equal to 10 is one variable I'm creating, and some methods I'll create. Public void. Let's say method A. Okay. Method A is one method I'm creating. And in this method, I'll just write a print statement inside method A. And I'll try to create one more method, public void method B. I'll try to create the body for this method. And if I add this abstract keyword before this method, the method will become an abstract method. And we are going to get a compiler error saying that for the abstract methods, we cannot have the method body. Okay, over the mouse on this, you see, abstract methods do not specify a body. So I have to remove this body for this method. Now put a semicolon. Still the error is not gone because if there is a class containing at least one abstract method, for example, this is not an abstract method because this method has a body and implementation is there, but this method only has a definition and method body is not there and it has the abstract keyword. So this one is going to be an abstract method. If a particular class contains at least one abstract method, the class also need to be specified as abstract type. Okay. Now this is an abstract class. But the question here is, can we create an object for abstract classes in Java? The answer is no, guys. Okay. Just try to create. Okay. For example, I'll just create new class. Let's say demo A class. I'll just create with main method. I'll create demo A. And from this class, inside this method, from the main method, I'll try to create an object for this abstract class. And you will observe that when you try to create an object for this abstract class, you should get some compiler error. Okay, try to create an object for the abstract class. You see, this class is now specified with abstract keyword. This becomes an abstract class. For this, for such kind of class, if you try to create an object like, you say new class, the 3, okay, I'll just copy this class name otherwise, okay. Class A like this. If I try to create an object, CA, I'll say, and create the, give the same class, okay, which I copied here. Because I'm getting an error here saying cannot instantiate the type class A. We cannot create an object for the class, okay? Cannot instantiate the type class A. Fine. Instantiate means object. Instance means object, right? Cannot create object for the type class A. So in Java, we cannot create objects for the abstract classes. Then there will be a question arising now. That is, if you are unable to create an object for abstract class, then how can you access the members of this abstract class? The answer is, in order to access the members of this abstract class, we have to create a child class. Okay, for this abstract class, create a child class. Let's say class AC. Okay, let's say C stands for child. I'm just giving some random names. That's okay. Finish. Now I'll make this class AC extends class A. Okay, now class AC is the child class of the class A. But when you create the child classes for an abstract class, the unimplemented methods in the, okay, the unimplemented methods in the parent class need to be implemented. Then only this error will go. You see, the type class C must implement the inherited abstract method, method B. Method B is just defined. It's an abstract method in the parent class, class A. Child class of this abstract class need to implement that. So the moment when you say public void method B, the error will be gone. The moment you try to override this method or just defined method in the abstract class, abstract parent class, right, in the child class, the error will be gone, guys. You see, the error is gone. Sum.out.println inside method B. Okay, like this, I created one sample print statement. Now, in order to access the members of this abstract class, that is this variable, this methods and all, okay, I need to create an object for the child class of this abstract class. What is the child class of this abstract class? Class AC is the child class. I'll copy this name. And if I try to create an object for this class AC, I can create an object for the child class. I can create an object for the child class of this abstract class. But I cannot create an object directly for the abstract class. But for that abstract class, I need to create a child class. And to that child class, I need to create an object. CAC. Okay, child class AC. And class AC. You see, I can create an object for the child class and using this object reference, now I can access the members of this abstract class and its child class. Okay. So you see, I can access the variable A. So already the value is there. So I'll just print it out. System.out.println. System.out.println. If I say cac.a, you see, I can access the members of the abstract class by creating an object for the child class, because child class will inherit all the properties of the abstract class, and child class is not an abstract class. It has implemented undefined methods of the abstract class. So it's a normal class. So we can access. Okay. Similarly, cac dot the method A. Method A you can access, you see. And this method which is overridden and implemented in the child class also can be accessed. Cac dot method B. I can access all the things. I can run the code and I can get the output without any problem. The value of A, that will be 10, will be printed along with that. Inside method A, inside method B also will be printed. Okay. So hope guys you got an idea or the answer for this question with practical demonstration in this session. Can we create object or objects for abstract classes in Java? The answer is no. We cannot create objects for the abstract classes in Java. Okay. If you try to do so, you are going to get a compiler error. Compiler error. What does the compiler error say? Cannot instantiate. EIAT. Okay. Cannot instantiate that particular class. Okay. Cannot instantiate the abstract classes. Such kind of error you will get. Okay. I can find out the error here. You see, when I try to create an object for the abstract classes, you see, cannot instantiate kind of a compiler error will come. I'm just commenting it out so that the error will go off. Okay. So what is the way to access the members of the abstract class then? For that particular abstract class, we have to create a child class. And if the child class has implemented the unimplemented abstract methods of the abstract class, okay, then by creating an object for the child class, we can access all the members of the abstract class. Okay. So that I have already demonstrated in this session. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, can we specify constructors with private access modifier? The answer is yes. While creating a constructor in Java programs, before the constructors, we can specify the private access modifier without any problem. Java will not give you any error or compiler error on providing this private access modifier before the constructor. Okay, so no error will come. But what will happen when you specify this private access modifier for a constructor in Java programs? What will happen? So this is what is going to happen, guys. So let's say there is a class. Inside the class, you created a constructor, and the constructor is now specified with a private access modifier. Now, the constructor inside this class will only be called when you create an object for the class, right? In the object creation statement itself, the constructor calling statement will be there, and that's how the constructor will be generally called. But this object creation need to be done within the class only. Why? Because the constructor is private. Okay, when the constructor is private, you cannot create an object for this class in which the constructor is there. Outside the class, you cannot do so. Okay, the constructor need to be called within the class. So you have to create the object, okay, for the class within the class itself, so that constructor calling statement also will be there within the class, and that's how the private access modifier specified constructor can be called. So hope you got the point. Let me practically demonstrate this for you so that you will be able to understand what I have explained just now in a better way. For that, I'll switch to this Eclipse IDE. I'll close all the stuff. I'll close all the things and just freshly create a new class and all those stuff. Okay, just give it some time to go. So last one. Yeah. Now freshly, I'll go to one package and, create some class. Okay. Constructor demo class. Okay. Some constructor demo or CD I'll give. Okay. The name of the class I'm just giving at CD or C demo class. Okay. Click on finish. The CDemo class has been created. And in this class, I'm going to create a constructor. Okay, I'm going to create a constructor. How to create a constructor? Without worrying about the private access modifier, first I'll casually create a constructor with public access modifier. And constructor, you already know, will not have any return type. So no return type, void or nothing should not be provided. After that, the name of the constructor should match with the name of the class. Like this. This is a constructor. I created a constructor here. I'll simply write a sample print statement inside constructor. I'll say simple. Okay. Now I'll change this public access modifier before this constructor with private access modifier. There won't be any problem, guys. You are not going to get any compiler error. Okay. This is a constructor, and before the constructor, I provided private access modifier. The question here is, can we specify constructors with private access modifier? The answer is absolutely yes. Okay. Before the constructor, you can mention private access modifier without any problem. Okay. There will not be any compiler error. But the only problem is, since this constructor is private, you can create. How can you call this constructor? In order to call this constructor, we have to create an object. Okay. So let's create a method here, public void sample method. Inside this CDemo class, I'm going to create a sample method. And inside this sample method, okay, I'm going to create an object for this class. How? New CDemo. The moment I do that, when I create an object for this class using new keyword, object will be created for CDemo, and this is a constructor calling statement. And since this particular method is within the class and this is private, this particular constructor is private to this particular class, so I can easily call this method. Okay, this object creation statement won't be any problem. CDemo is equal to like CDemo I can give, no problem, guys. Okay, when I create this object creation statement, this is end full object creation statement, guys. And as part of this object creation statement, there's a constructor calling statement, and this constructor calling statement is within the class. Since this constructor is private, I can call this class from within the class. I can call this constructor from within the class by creating an object like this. There won't be any problem. That's not an issue. Okay, this is not an issue, guys. I can also write this public static if I want. Okay, instead of this normal method, I can write main. Now, like this, I can write string of args. Okay, and all good. Okay, so when I run this code, the main method will run, and as part of that, object will be created, and this constructor calling statement will be there, and this private constructor will be called, and this print statement should get printed in the output. Okay, it should work fine. You see, instead constructor got printed means the constructor has been called. But what if I'll make this again, I'll just comment this out for a while. Okay, so that this code doesn't exist now. Now I have a class and have a constructor which is specified with private access modifier. So this constructor can be called only within the class because it is specified as private. Outside the class, from outside the class, I cannot call this constructor because it is private. So I'll go outside the class. I'll just say C sample. Okay, C sample, and I'll just create a main method here. Inside this sample, I'm just going to, you see, this C sample is outside the class, right? And this constructor is within the class. Outside the class, within the main method. Okay, within the main method, when I try to create an object for this class, new CDemo. Okay, outside the class, from outside the class, if I'm trying to create an object for this class, for the CDemo class, what is happening? Error is coming. Why? The constructor CDemo is not visible because this CDemo constructor, okay, the constructor of this particular class is specified with private access modifier. So within the class only, we can access this constructor. The constructor calling will only happen, okay, from within the class. But from outside the class, if you try to create an object for this class, it will not allow because this constructor calling statement cannot happen here because this is private type. Private cannot be accessed outside the class. Within the class only can be accessed. Hence, object creation won't be possible. Okay. Outside the class, the object creation won't be possible. The constructor is specified with private access modifier. So the question here is simple, guys. Can we specify constructors with private access modifier? The answer is yes. But the consequences are you cannot create objects for that particular class which is having the private access modifier specified. Okay. From outside the class, you cannot create an object. Within the class, you can create an object for that kind of classes having this private access modifier specified constructors. Okay. To call the constructor, we have to create an object within the class. But from outside the class, we cannot call the constructor. Hence, object creation won't be possible, and we'll get the compiler error saying that that particular constructor is not visible or kind of, okay, as I have demonstrated clearly in this. Okay, from within the class, I can create an object for this class, and constructor will be called. This private access modifier specified constructor can be called within the class. But from outside the class, from another class, if I try to create the object for the same class, I'll get an error because this constructor calling statement may not is not possible because this constructor is private to this class, so it cannot be called outside the class. Simple words, okay? So hope guys you got the answer for this question. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, can we specify constructors with static modifier? The answer is no. What will happen when you specify the static modifier before a constructor in Java? It is going to give you the compiler error. Java compiler is going to give you the compiler error saying illegal modifier. Such kind of static modifier cannot be specified before the constructors. Hence, can we specify constructors with static modifier? The answer is no, guys. The reason why the Java is not allowing the, okay, why Java is not allowing us to specify the static modifier before a constructor, why it is giving a compiler error, that we'll understand later. But first, with the help of programs, let's understand whether Java is really allowing us to specify the static modifier before a constructor, or is it giving compiler error? The answer is it will not allow, guys. It will give the compiler error. Illegal modifier kind of error will come, that I'm going to show you practically first. For that, I'll switch to this Eclipse ID and create a new class. I'll just name this class as on demo, constructor demo, short form. I'm giving some random name. Click on finish. Once I create the class, inside the class, I'll create a constructor public. Constructors will not have return type, and the name of the constructors should match with the name of the class. So like this, okay? The name of the constructor should match with the name of the class. Till now, there is no error. Okay, if I write something like this inside inside constructor and all, I can write inside constructor. Okay, constructor. Done. All good. Okay, without any Java compiler errors and all, we were able to create a constructor. But the moment I add static keyword or static modifier before a constructor, I'm immediately getting a compiler error saying illegal modifier. Static modifier cannot be specified before a constructor. Why Java is not allowing us to specify the static modifier before a constructor? That we have to understand now. Okay, anyhow, when I provide static modifier, I'm getting a compiler error, as I mentioned here as an answer for this question. Okay, can we specify constructors with static modifier? The answer is no. Instead, we'll get the compiler error saying illegal modifier. And because of that error, we have to remove the static modifier before the constructor. Okay, but what is the reason for the Java not allowing us to specify the static modifier before a constructor? That we have to understand. Okay, what is the reason? Okay, I have to now explain you why Java is not allowing us to specify static modifier before a constructor. Before a constructor, why Java is not allowing us to specify a static modifier? So to understand or to get the answer for this particular question, we have to understand the purpose. What is the purpose of the constructor? Okay. To get the answer for the first question, we have to understand the answer for the second question. That is, what is the purpose of constructors? Why in Java we have constructors? What is the purpose of constructors in Java? How constructors will play a key role in Java? Constructors help us in initializing the class variables with different values for different objects. Okay, you have to understand this statement, guys. Okay, the main purpose of the constructors is to simplify the initialization of the class variables with the different values for different objects. Okay, so the constructor is all about initializing the class variables with the different values for different objects. If you create 100 objects for the class, okay, let's say you have created 100 objects for the class, and for each and every 100th object, okay, each and every object in that 100 objects, we have to assign different values for the class variables for that particular object. Object 1 will have different values assigned for the class variables. Object 2 will have different values assigned for the class variables. Object 3 will have different values assigned for the class variables. object 4 like that till object 100 different values, okay, will be assigned for the class variables respect to the objects. And the constructor actually simplifies this process of initializing these class variables with the different values for different objects. But what happens the moment you provide static keyword before a constructor or static modifier before a constructor? So you know that the constructors will be called when you create the objects. When you create that 100 objects, every time you create an object in that 100 objects, the constructor will be called and the class variables will be initialized with the values specific to that particular object, different values specific to that particular object. That's what happens. And constructor will do its job of simplifying the initialization process for that class variables for that particular object. Okay. But if you provide static, what happens is without creating an object, constructor can be called, right? The moment you make a constructor static, what happens? Without creating an object, you can call a constructor. How? Whatever that is static inside a class can be called with the help of class name. Whether it may be a variable or method, you can provide static modifier before a variable or method. And if a class contains a variable or method, which is provided with static modifier, that variable or method can be accessed outside the class with the help of class name dot variable, class name dot method. But if you do the same thing for constructor, if Java allows you to specify static modifier before a constructor, even the constructor can be called with the help of the class name dot constructor name. Like that can call. Okay. But static means common. Okay. It's not related to different values cannot be stored. Different values for class variables cannot be stored for different objects if you make the constructor static, because static means common memory. So same values for all the objects. Okay. If you make the constructor static, the same values for all the objects will be there. Okay. You have to initialize the class variables with the same values for all the objects. But with the help of constructors, since constructors are not static type, when you create an object for the constructor, for that particular object, constructor will be called, and the different values that you are passing from the object creation statement will be passed to the constructor, and the constructor will initialize the class variables with the different values for that particular respective object. But if you make it static, you have to pass only one time. You have to call the constructor only one time and assign the same values for all the objects. Common values will be there. That is against the Java, guys. Okay, that is against the Java, and that is against the functioning of the constructor. The purpose of the constructor, if you understand properly, you'll understand why constructors cannot be provided by static modifier. If you provide the constructor with static modifier, for even though you have 100 objects, for each and every 100 objects, same values need to be stored for all the class variables. Okay, the price of the car will be same, the model of the car will be same. Okay, the color of the car will be same. It won't be correct, right? Different cars will have different colors, models, company, price, etc., mileage, etc. So to initialize these class variables such with the different values. Okay, in this example, I am taking car. Okay, if you create an object for the car class, and let's say there is some XYZ car, that car will have a different color, different price, different mileage, different model, different company, etc. Right? So I have to assign such kind of different values for different objects. For every car, I create a different object, and then I'll try to initialize these class variables with different values according to that car object. Okay, but if I make the constructor static, what happens? I can call the constructor with the help of the class name and without even creating an object. So only one time I can call the, only one type of values I can store into the constructor, initialize with the help of constructor. And because of which the same values will be there for all the objects. Every car cannot have the same color. Every car cannot have the same price. Every car cannot have the same model. Okay, same mileage, same company, etc. So static means common. Class memory, common. Here object memory stuff will come into picture when you don't provide static before a constructor. So we have to create an object in order to call the constructor. For every object, you will be calling the constructor to initialize the different values for different class variables for that particular object. But with static, only one time I can call the constructor, or even though I call multiple times, only one type of values can be stored for all the objects. Okay. Hence, constructors cannot be specified with static non-access modifier. Okay. So this is the reason, guys. Okay. Why Java is not allowing us to specify static modifier before a constructor? This is the reason. Okay. The purpose of the constructor, if you understand why Java is not allowing us to provide static modifier, you will understand. Okay. This is the line you have to understand, guys. Constructors help us in initializing the class variables with the different values for different objects. But with by making the constructor static, same values for all the objects will come. Okay, initializing the class variables with same values for all or different objects will come. All the objects, different objects will have the same values, same price, same model, same company. That's the problem if you make it static. Hope you got the idea. Okay. So hope guys you got the reason why the Java is giving a compiler error when you specify the constructors with static modifier. Okay, that is the reason. With practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what will happen when we specify final modifier before a variable in Java? When you provide final modifier before a variable in Java, the value that is first initialized to that particular variable cannot be updated. That is going to be the final value of the variable. Okay, as the name final speaks, the value that is initially assigned to the variable cannot be updated anymore. So what literally happens when you are writing a Java program and creating a variable, and if you mention final modifier before that variable, then first you will get a compiler error saying you have to initialize the variable with some value. If you don't initialize, Java compiler will give you error for the variables which are specified with the final modifier. Okay, it's compulsory for us to initialize the variable with some value. That's first thing. And after that, after you initialize it, if you try to update the value that is initialized to that particular variable, then again Java compiler is going to give you the compiler error saying you cannot update the value of any final modifier specified variable. It's going to the final value. Okay. You have to either remove the final modifier before the variable, or you should stop your activity of updating the value of a final variable. Okay. That's what happens. Let me practically demonstrate this for you so that you will be able to understand the answer for this question in a better way. So fine, I'll go here and create a new class. I'll simply say final demo. Click on finish. And now here I'll create a method, guys. Public void some sample method I'll create just for the sake. Okay. So once I create a sample method here, before the method directly under the class, I'm going to create a variable. Let's say int a is a variable name. Okay. Int a is a variable. Have declared this variable. You see, I'm not getting any compiler error. Even though this particular variable is not initialized with any value so far, I'm not getting any error because it's not specified with any final modifier till now, right? The moment I provide final modifier before this variable, immediately Java compiler will give me an error saying you have to initialize this variable with some value. The blank final field may not have been initialized. Initialize final field, a declaration itself, wherever you have declared that variable, at the same line, you have to initialize. Okay, for now, as per the error message, you have to initialize. Okay, the simple thing is that when you mention final modifier before a variable, Java compiler will ask you to initialize this variable with some value. Let's say I initialize this variable with some value, let's say 10. According to the data type of the variable, I have given some value 10 because it's now you see the error is gone. All looks good. Okay. The final variable, final modified specified variable compulsory need to be initialized. That's the first thing. Java will take care of that thing first. Okay. The important thing that Java also takes care of is this value is final for this variable. The first initialized value of this particular variable is the final value. If you try to update the value in other areas of the program, if you try to change or update the value of this variable a from 10 to some, let's say 20, let's say, if I try to update the value of the variable a from 10 to 20, again, I'm getting a compiler error. The final field a cannot be assigned. You cannot update the value of the final variable. This is the final value. You cannot update it anymore. Okay. These are the things, guys, you have to take care. Okay. So what will happen when we specify the final modifier before a variable in Java? The value that is first initialized to that particular variable cannot be updated anymore. That's the main thing, guys. Okay. But when you write the program, okay, initially, if you don't initialize the variable which is specified with final modifier, Java will give you a compiler error asking you to initialize the variable. Okay. If you initialize the variable with some value, proper value, the error will go off. And if you try to update the initialized value with some other value, in the rest of the program, then again Java will give you the compiler error saying that the value of the variable cannot be updated because it is a final variable. Final variable values, okay, once initialized cannot be updated. Okay, so with practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what will happen when we specify final modifier before a method in Java? Let me answer. If we specify final modifier before a method in Java, that particular method cannot be overridden by the child classes. Okay, whatever the method before which you have added the final modifier, that method cannot be inherited by the child classes anymore. Okay, so with practical demonstration, I'm going to answer this question for you. Further, I'll switch to the Eclipse ID, and here I'm going to create a new class. I'll just name this class as parent class. Okay, intentionally I'm giving the name as parent class, though it's not a parent right away. Okay, so parent class I created. And in this parent class, I created some method, let's say public void sample method. Okay. So here I'll say system.out println inside sample method of parent class. Okay. I created this. Done. Now I'm going to create one more class. I'll just name this class as child class. Okay. Just naming is child class. It's not really child class now, the moment I'm creating, but I'm just giving the name as child class. Okay. So here we have the parent class and here the child class. This is not a child class of this parent class. To make this particular class a child class of this parent class, I have to use extends keyword, extends, and the name of the parent class I have to give. Okay. Now this particular class has become the child class of this particular parent class. Okay. So this has become the parent of this child class. This child class has become the child class of this parent class. Okay. So now before I add any final modifier before this sample method, you see, I have not added any final modifier before this sample method in the parent class. Okay. And if I try to override this method in the child class, I will be able to do so without any problem. I will not get any problem. Public void, the same name. Okay. Whatever the method name that the parent class has, the same name I am creating again in the child class. This method anyhow will be inherited by the child class. At the same time, child class also has the same method having the same name by itself. System.out.println inside sample method of child class. Now, at this situation, I can say that this particular method is overriding this particular method in the parent class. Okay. This method in the child class is said to override this method in the parent class. On the top of that, we can also add @override notation. Okay. On the top of this method, we can write because we are actually overriding. If this particular method is not overriding this method in the parent class, even when you provide this @override annotation, you will get a compiler error if this method is not overriding the method in the parent class. Okay. Otherwise, when you provide this @override annotation before this method, if this method is really overriding this method, then you are not going to get any compiler. It works fine. Okay. Now, what I'll do is I'll add the final keyword. So far, I have not added any final modifier before this sample method in the parent class. Okay. Before adding that, we can see that clearly that this particular method is being overridden by the child class. Okay. By creating the same duplicate method in the child class. But what if I add this final modifier for this method in the parent class and save this? The moment I save this, you see, the moment I add final modifier before this method and save this, you see, I'm getting an error in the child class for this overridden method. Okay. You cannot override anymore. The final modifier specified methods cannot be overridden by their child classes. Over the mouse, you can see that cannot override the final method from parent class. You have to remove final if you want to override this method. Okay. This method cannot be overridden. Okay, this method cannot override the method in the parent class because the method in the parent class is now specified with final modifier. So this is what happens, guys. Okay, when you specify final modifier before a method in the parent class, that method cannot be overridden by its child classes. That's the answer. So hope guys with practical demonstration have answered this question for you. That is what will happen when we specify final modifier before a method in Java. That method cannot be overridden by its child classes. Okay, by the child classes of this particular class in which the method is specified with final modifier. The child class cannot create a method which can override the method in the parent class. Okay, which is specified with final modifier. So that's all for the session. Thank you. Bye bye. Hello all. Welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what will happen when we specify final modifier before a class in Java? Let me answer. When we specify final modifier before a class in Java, this class cannot be inherited by other classes. That means we cannot create child classes for the class which is specified with the final modifier. Okay, we cannot create child classes for a class which is specified with the final modifier, or this class which is specified with final modifier cannot become a parent of any other class in Java. Simple words. Okay, so let me practically demonstrate this one for you. For that, I'll switch to this Eclipse IDE and I'll create a new. Freshly, I'll create a new class. Write it new. I'll simply name this class as P class. Let's say I'm just naming this as P class. Okay, and for sample, I'll create a variable and method in this class, public void sample method. Okay. So I'm just creating some class with the name P class. You can give any name. System.out.println. Inside sample method. Inside sample method, I'll write. Inside sample method, I'll write. Okay. Now we have a class. Now I'm going to create another class. New class. I'll just name this class as C class. Just naming as C class. Click on finish. Now I would like to have it side by side. As you can see, both the classes. Here we have the, sorry, let me take this off and take this down. Okay. Okay. Like this. Okay. So here we have the P class and here we have the C class. Okay. Now, this is a normal class. Okay. This class that you see here on the top is not specified with any final modifier. Okay. I have not specified the final modifier before this class. So this class can become a parent of any other class in Java. For example, I would like to make this C class a child class of this P class. I would like to make this P class a parent of this C class. Okay. So for that, I would write extends P class. I'll not get any compiler error because this particular class is not yet specified with final modifier. So this class can be inherited by any other class in Java. Okay. So we can make this particular class inherited by any other class in Java. Using extends keyword, I can make this as a child class of this P class. Okay. Inheritance is possible and this class can become a parent of other class. That's all you can see, right? But the moment I put final here and click on save button here, you can see that there is an error coming in the child class. Okay. That is, the class which is specified with the final modifier cannot be inherited by or cannot become a parent of any other class, or any class cannot become a child of this class which is specified with final modifier. You see, I'm already getting an error saying that the type C class cannot subclass the final class P class. Okay, if the class is going to be a final class, that class cannot become a parent of any other class. That cannot be inherited by any other class in Java. That is the intention of the final, guys. Okay, so I'll just comment it out so that this is not possible, right? So I'm just commenting it out. So the class which is specified with final modifier cannot be inherited by other classes, or can the class that is specified with final modifier, for that class we cannot create child classes, or the class which is specified with final modifier cannot become parent of any other classes. Okay, cannot. Like this, you can give any answer, guys. So all the answers are pointing to the same thing, right? Okay, cannot be inherited by other classes, cannot become a parent of other classes, or other classes cannot. Okay, for that class we cannot create children. Okay, other classes cannot become children of this class which is specified with final. All are the same answers. Okay, and explained in a different way. You can give any answer out of this. Okay, and that will work out as an answer for this question if you come across such kind of question in the interviews. So with practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, can we create an object for an interface in Java? The answer is no. We cannot create an object for an interface in Java. If you try to do so, you are going to get a compiler error. Okay. If you try to create an object for an interface in Java, we are going to get a compiler error. So the compiler error will say cannot instantiate. TIAT. Okay, TIAT. Okay, cannot instantiate for this particular interface. Okay, cannot instantiate an interface, it will say. The reason is we cannot create an object for an interface, guys. Interface or abstract classes, we cannot create object. Okay, in Java, for all the other classes, we can create objects, but except for the abstract class and interfaces, we cannot create, okay? We cannot create objects, okay? Because these abstract classes and interfaces are all about, what you say, abstraction, hiding. So some of the things will be implemented and some of the things won't be implemented in the abstract class. Hence, we cannot create an object for the abstract class. And coming to interface, it's complete abstraction, guys, full abstraction. So nothing will be implemented in the interface. All the things will be defined in the interface only. Only definitions will be there in the interface and implementation won't be there. Hence, there is no need of creating an object for an interface. That's what Java believes. And in abstract classes also, since everything is not implemented in the abstract classes, something is implemented, something is not implemented. That is partial implementation is there in the abstract classes. So hence, Java feels that it's not a good thing to create an object, okay, for that abstract class, because some of the things are partially implemented, some things are implemented, some things are not implemented. So then how to access the members of this interface or abstract classes? By creating the child classes, okay? We can create the child classes for this partially implementing the abstract classes or fully abstracting interfaces. And in the child class, whatever that are not implemented in the interface or abstract classes, we are going to implement. And for that child classes, we can create object, and using that object reference of the child classes, we can access all the members of the abstract classes or interfaces. That's what we do in Java, okay? So simple straightforward answer for this question is, can we create an object for an interface in Java? The answer is no, guys. We cannot create an object, okay, for an interface in Java. And if you try to do so, you are going to get a compiler error saying cannot instantiate. I'm going to practically show you that how you are going to get a compiler error on trying to create an object for the interfaces in Java, okay? So further, I'll switch to the Eclipse IDE. I'm going to create an interface, guys. How to create an interface? Right click on this and click on new. And here, instead of selecting a class, just select interface option. Okay. When you select interface option, you have to give the interface name, guys. Okay. So don't select a right click new class option. Select right click new interface option. So here, give some name like interface A. Okay. I'm just giving some name like interface A as the name for the interface. And the interface will get created. And here you see the interface keyword will be there. Okay. Before the interface name, interface keyword will be there. For the class keyword will be there. But for the interface keyword will be there. Okay. So inside this interface, whenever you create method, by default, the methods will not have any body. If you try to create, okay, method with body inside this interfaces, you are going to get some error, because by default, all the methods inside the interface are abstract type by default. Even though you don't specify abstract keyword before the methods in this interface, by default in the interface, all the methods public void, if I create a method like sample and try to create a method body here, you see, starting of the method, ending of the method. If you try to implement this method, immediately Java compiler will give you an error because abstract methods do not specify a body. Even here, I didn't specify an abstract keyword, but by default, the methods in the interface are abstract type. Hence, the methods cannot contain body. Okay, I have to remove this and put a semicolon. You see, only definition of the methods is possible for the interface. Okay, like that you can create any number of methods, but all the methods should only be declared, guys. They cannot be implemented. Okay, so for example, public void, if I say method 2, it cannot have method body. Again, you'll get the same error saying abstract methods do not specify a body. By default, the methods in the interface are abstract type. Okay. Even though there is no abstract keyword here, by default, they're abstract type. Okay. So like that, no matter how many methods you create, all the methods inside the interface are going to be abstract type by default, and they cannot contain a method body. Okay. They cannot be implemented. They can only be defined. Now, let's see whether we can create an object for the interface which has this methods which are not implemented. Here, full abstraction, guys. Nothing is implemented. Only definition stuff is there. Okay. We generally create an interface to define something. Okay. But we are not going to write any logic for any of these methods. Okay. In the interface. So full abstraction is there. So Java believes that creating an object for an interface, what you will access? These methods which are not implemented. What is the use of accessing such kind of methods which are not implemented in an interface? Is there anything happens when you create an object for this interface? That's why Java believes that let's not create an object. Okay? Let's not allow the users to create an object for the interface, because even the users try to create an object for the interface, what they will get by accessing these methods which are just defined but not implemented. That's what is the problem that Java thought. And so as per the rules and regulations of Java, Java have decided that either for abstract classes which have partial implementation or for interfaces which have full abstraction, no implementation at all. There is no use of creating objects because by using that object reference, we cannot access anything. Okay, there is no use of doing that. Okay, so it's better to avoid the restrict the users from creating object. That's what Java thought of. And even if you try to create an object, Java will give you a compiler error saying that objects cannot be created for the interfaces or abstract classes. Okay, so I'll try to create one, try to create one class. Okay, idemo. Okay, idemo, and with main method I'll create. And in this idemo, I'll try to in this class, I'll try to create an object for this interface, and you can see that objects cannot be created for the interface in live. New interface A. If I try to create an object for the interface, immediately I'm getting an error. You see, this new keyword in Java can be used for creating an object, right? If I try to use a new keyword for creating an object, you see I'm getting an error saying cannot instantiate the type interface A. Okay, I is equal to interface A. This is a full object creation statement. Doesn't matter, guys. Okay, the same error will come. Cannot instantiate. We cannot create object for the interface. This is the proof. Okay, if you write this kind of object creation statement, you already got an error here saying that cannot instantiate the interface. Okay, so fine, guys. So hope guys you got an idea like or answer for this question with practical demonstration in this session. Can we create an object for an interface in Java which has full abstraction, no implementation at all? Java believes that by creating an object for that interface, what is the use? Okay, using the object reference, can we access some methods which are just defined in the interface? Right? That's what Java thought and has restricted us from creating an object for such kind of interfaces. And hence Java will give you a compiler error if you try to create an object for the such kind of interfaces saying cannot instantiate. But how to access these members? If I really want to access these members of this interface, what I have to do? I have to create a child class for this interface. Okay, I have to create a child class for this interface, and using the by creating an object for the child class of this interface, we can access the members of this interface. Okay, I'll show you. Right click, new class. I'll say CI class, child class of the interface. Some wording I'm giving. That's okay. Click on finish, and I'm going to make this. Just drag it here, and I'm going to make this child class. This CI class as child class of this interface A. How to do that? Here I should not be using the extends keyword for interfaces. If you want to make a particular class in Java to become a child class of an interface, we have to use implements keyword. Okay, but for making a class a child class of another class, we have to use extends keyword. But for making a class a child class of an interface, you have to use implements keyword. And here I'll say interface A. The moment I say interface A, I'm getting an error here. The reason behind this error is there are some unimplemented methods in this interface which are just defined in the interface. Since you are the child class of this particular interface, okay, you have to should and must implement. Okay, should and must this particular child class should implement, or this child class itself should become an abstract class. I have to add the abstract keyword if this child class don't want to implement any of these methods of the interface. Okay, or if I don't want to provide abstract keyword here, I have to implement this unimplemented methods of this interface in the child class. Okay, so how to implement? Just try to override. That's it. Public void sample. Okay, I'll just create the methods. So here I'll say system.out.println inside sample method. Okay, method. And one more thing I'll say here is I'll create, there is one more unimplemented method, right? That's why error is not going off, okay? There is one more unimplemented. You can hover the mouse and you can see that must implement the inherited method, that is method 2 need to be implemented. Then only the error will be resolved, okay? Only one of these two methods which are defined in the interface are implemented by its child class. So I have to implement that method also. Public void method to have to implement, method to have to say, and like here, write down system.out.println, system.out.println inside method 2. Okay, inside method 2. Okay, that's it. Now click on save, and now the methods which are just defined, okay, in the interface are implemented by its child classes. So though we cannot create an object for the interface directly, we will get a compiler error saying cannot instantiate, but we can create an object for the child class. But we can create an object for the child class, and by creating an object for the child class using the object reference of the child class, we can access all the members of this interface which are implemented in the child class. Okay, so how? New, what is the name of this class? CI class, right? Child class. Okay, new class. Sorry, like this I can say, and here CI is equal to, I'll just declare this with the same name. Okay, So I can create an object for the child class of this interface, and using the object reference of that child class of the interface, I can access the methods. That is a sample method I can access, ci dot method 2 I can access, and all. Okay, and so on. Okay. So we cannot directly create an object for an interface to access the members of this interface, but we can create an object, but we can create a child class for this interface, and by creating an object for child class, we can access the implemented methods of this interface from the child class. Okay. So hope guys you got a detailed answer. Okay. So why we can't create an object for an interface, or can we create an object for an interface in Java? The answer is no. But we can create a child class for this interface, and for that child class, in the child class we can implement the unimplemented methods of the interface, and then for that child class we can create an object and access the members of the interface. Okay. So hope guys you got the answer for this question. So that's all for this session. Thank you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what is the keyword for creating an interface in Java? Let me answer. We have to use a keyword known as interface keyword, followed by the interface name. Okay. In order to create an interface in Java while writing the Java programs, we have to use a keyword in Java known as interface keyword, which is followed by the interface name. For example, it will be like this. Okay. Interface, interface name. Like this, we have to create an interface in Java, starting of the interface and ending of the interface. Okay. So like this. Okay. There is some code in between the interface and all. Okay. So interface is a keyword that we have to provide before the interface name while creating an interface in Java. But for creating a class, we have a class keyword. But for creating an interface, we have to use interface keyword, not class keyword. Okay. So let me practically demonstrate how to create an interface in Java with the help of this interface keyword. For that, I'll switch to this Eclipse IDE. Here I'm right clicking on a package and selecting new. And here, when you are creating an interface in Eclipse IDE, instead of selecting this class option, you have to select the interface option. Okay. But if you are writing this, creating an interface without the help of Eclipse IDE, let's say in the normal notepad or something. For example, if I open the normal notepad editor, okay, then how to create that interface I'm going to show you. So I'll just create a new thing. So here, okay, I'll show you here. Fine, give me a second. So here, if I have to write some Java code to create an interface, I have to write like this: public, followed by, this is optional guys, public is optional. Whether you want to provide public or not, it's up to you. But if you provide, generally most of the interfaces will have this modifier mentioned, access modifier public mentioned. So that is optional anyhow. But the main thing that you have to use, or the main keyword that you have to use for creating an interface in Java is the interface keyword. Okay. The interface is the name of the keyword followed by the interface name. Let's say sample inter. Okay. Sample interface. Okay. I'm just giving some random name for the interface. Okay. And the starting of the interface and ending of the interface. This is starting of the interface and this is the ending of the interface. Okay. In between that, you can create some methods and all. Okay. Method definitions and all. Okay. So interface is the keyword name that we have to use, or the keyword that we have to use for creating an interface in Java. So in Eclipse IDE automatically creates that code for us. So I will not be able to show that. That's the reason I have written that code for you in the normal notepad editor instead of Eclipse IDE editor. But if you try to do the same thing in Eclipse IDE, you should not be selecting the class option while creating the interface. You have to select the interface option having this eye icon. Select that. It will ask you the interface name. So sample demo interface. Okay, just give some name. Okay, so it's in upper camel case anyhow. The naming convention of the interface need to be in upper camel case. When you click on the finish, Java will this Eclipse IDE will automatically generate this Java code containing the interface keyword and followed by the interface name. Okay, it generally don't write such kind of code in the Eclipse IDE editors, but if you are using normal editors like Notepad and if you have to create an interface like this, we generally type it. But Eclipse IDE automatically generates this code. As you can clearly see, Eclipse IDE has used the interface keyword for creating an interface in Java. Okay. So the answer is what guys? Interface. But for creating a class, if I open any other classes here, for example, any of the class here, the class keyword will be there. Okay. So this is commented out. Let me open some other sample class or something. As you can see here, you see For creating a class, we need class keyword, but for creating an interface, we have the interface keyword in Java, guys. Okay. So what's the answer for this question? So what is the keyword for creating an interface in Java? Interface is a keyword which we have to use for creating an interface in Java. So hope guys you got the answer for this question with practical demonstration. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, can we specify abstract keyword before a variable in Java? The answer is no. Abstract modifier or keyword can only specify before a method or class in Java. If you try to specify this abstract modifier or keyword before a variable, Java is going to give you a compiler error. The answer is no. And if you try to do so, you're going to get a compiler error saying illegal modifier. Illegal modifier kind of compiler error you'll get when you try to create a variable and specify this abstract modifier before that variable. Okay. So in Java, if you have to specify the abstract modifier is allowed to be specified either before a method or class, but not before a variable. Okay. So abstract modifier can only be specified before a method or class, methods or classes. Simple. Okay. But variable is not allowed. Okay. So I'll show you practically what happens. So when you try to specify this abstract modifier or keyword before a variable, we will get a compiler error saying illegal modifier. So right click on this and create a new class. Okay. And now just do one thing, give some class name. Let's say ABS class. Okay. So just giving some random name, clicking on finish. Inside this class, I'm going to create a variable and method. Int a is equal to 10, some variable I'm creating, or int a otherwise. Okay. Some method public void sample method. Okay. Just for the sake I'm creating some variable and method. In this method, I'll create some print statement saying some sample statement inside sample method. I'll write down. Okay. Instead of keeping this method empty, I'm just writing a sample print statement. Now there is a class, there is a variable, and there is a method. Java allows you to specify the abstract keyword or modifier either before a class or before a method, but not before a variable. Okay. If I specify that abstract modifier before a variable, I'm going to immediately get an error. You see, compiler error has already come. For this method, I can mention abstract. For this class, I can mention abstract. But for a variable, I cannot mention abstract. Okay? So over the mouse on this, illegal modifier kind of compiler error is coming saying that such kind of abstract modifier or keyword you cannot specify before a variable in Java. So you have to remove that. I'll comment it out for a while. So I wanted to show you practically. Okay. So what happens when we specify abstract keyword or modifier before a variable in Java, it's going to give you a compiler error saying illegal modifier error. Okay. So with practical demonstration, I have answered this question for you. Can we specify abstract keyword before a variable in Java? The answer is simply no. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what is the naming convention of interfaces in Java? Let me answer. We have to name the interfaces in upper camel case. Similar to the project names, that is Java project names or Java classes. We also have to name the interfaces in upper camel case only. Okay. So that is the way we have to name the interfaces in Java in upper camel case. So what actually the upper camel case means, I'm going to explain now. Okay. So there are two conventions for namings in naming anything in Java. One is like lower camel case, we call lower camel case. And the other side, we have the upper camel case. Okay. Other way of naming something in Java is upper camel case. Okay. We either name something in Java in lower camel case or upper camel case. Okay. Or lower case. It depends on situations. So lower camel case means I will give an example. Okay. So like this, sample method one. Okay. So sample method one is a lower camel case. Why? Because there are three words. If you clearly observe in this example, there are three words in this single name. The first word's first letter is in lowercase. Remaining letters of the word anyhow will be in lowercase. But second word, if you see, the first letter of the second word is in uppercase. And third word, first letter is also in uppercase. And so on. Except the first word's first letter, remaining all words first letter while naming something in Java, okay, need to be in uppercase. Such kind of case that we apply for some things in Java like variables, methods, right, is lower camel case. We apply the lower camel case for variables and methods. While naming the variables and methods in Java, we apply the lower camel case, okay, where first words, first letter will lowercase and second word onwards, the first letters will be in uppercase. Whereas in upper camel case, how it will be different? You see, I'll just write something here. Sample, okay, sample interface 1, okay, interface 1. Here also we have three words, okay, in this example. While naming an interface, we have to follow the upper camel case where starting from the first word itself, the first letter of the first word starting itself will be in uppercase. S is in capital, I is in capital, O is in capital, and remaining all words also, the first letter of the words will be in capital. That is upper camel case, okay? So for what all the things in Java we use upper camel case for naming? While creating classes, if you have to name the class, we have to use upper camel case. While creating an interface, if you want to name an interface, you have to use upper camel case. Okay. If you want to create a Java project, while naming the Java project, you have to use upper camel case and so on. Okay. So for variables methods, we use lower camel case in Java, and for interfaces and classes, project names, we use upper camel case. Okay. I can also Google it out and show you like what upper camel case means, lower camel case means. Okay. Upper camel case, lower camel case, and just Google search and go to the images, guys. Go to the images, and the images you will find out two camels. Most of the people will be able to see two camels. Okay, when they Google search like this and go to images, as you can see, this is the lower camel case where you see the first word, it doesn't have the bump. First letter doesn't have the bump. Okay, so C is in lowercase. The entire word is in lowercase. Okay. Second word onwards, remaining words are in lowercase. Letters are in lowercase, but the first letter of this second word onwards is in uppercase. Okay. But here in the upper camel case, starting from the first word itself, we have the bumps, right? Like the first letter of the first word and second letter, second words first letter, third words first letter, fourth words first letter, all will be in uppercase. Okay. So this is the difference between the upper camel case and lower camel case. And for the interfaces, while naming interface in Java, we have to use upper camel case. Let me practically demonstrate this for you. So I'll create an interface for you, and while creating an interface in Java, okay, while creating an interface in Java, I'll follow the upper camel case. I'll select the interface option here, and I'll give some name, sample interface demo. I'm just giving a different name, demo 1. Okay. No matter how many words I give, there are 4 words here, and each and every word, the first letter is starting letter is in upper camel case, uppercase. S is in uppercase, I is in uppercase, D is in uppercase. 4 words. First letter of every word is in uppercase. That is called as upper camel case. I'm naming this interface here while creating an interface. Click on finish. The interface will be created. Okay. And the naming have done in upper camel case. Not only this, while creating a class or while creating a project, we have to name that in upper camel case. So hope guys, with practical demonstration, I've answered this question for you. That is, what is the naming convention of interfaces in Java? It is in upper camel case. We have to name the interfaces. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what happens when we specify abstract modifier before methods in Java? Let me answer. When we specify abstract modifier or keyword before method or methods in Java, then we cannot implement that methods. Okay, the methods before which you specify abstract modifier, that methods cannot be implemented. You cannot have the method body. Okay, the methods having this abstract modifier specified cannot have the method body. Only declaration part of the method can be there, but you cannot implement the methods, or the methods cannot have method body. Okay, So if you try to implement such kind of methods which are specified with abstract modifier, Java compiler error will come saying that this is an abstract method. It cannot contain or okay, it cannot be implemented. Method body cannot exist for such kind of methods, kind of compiler error you are going to get. Fine. And also, once a particular class contains at least one, okay, if you make inside a class, there may be multiple methods. If at least one method, even one method in that particular class, if you make it abstract by specifying the abstract modifier before a single method in that class, then you have to make that particular class also as abstract type. You have to specify the abstract keyword before that class. Otherwise, you will get a Java compiler error. Okay, there are two things that will happen when you specify abstract modifier or abstract keyword before a method. First thing is that you cannot implement the method. The method cannot have the method body. Second thing is that you have to make the class in which that particular method is available also abstract. These two things. Otherwise, you're going to get compiler errors. Let me demonstrate this in a practical way so that you will be able to understand the answer for this question in a more better way. Okay. For that, I'll switch to this Eclipse IDE. Here, I'm going to create a new class. Right click on this package and say new. I'll just say class. Sorry, I just selected wrong option. Right click, new, and then say class. And here ABS demo. Okay, I'm just giving some random name. Okay, abstract demo, something like that. Click on finish. So once I create this class, here inside the class, I have to create a method. Okay, inside the class, I'll create some methods. 2 to 3 methods I'll create. What's the matter? Public void sample1 is one method. Okay, here some print statements also I'll write. I'm implementing this method. This is a normal method I can implement. Okay, I can write the logic for this method. This is starting of the method, this is the ending of the method. As you can see, the method is getting implemented here because this is a normal method. And for this method, I have not mentioned any abstract modifier or keyword it. So I can implement the methods inside sample one method. Okay. Similarly, I can create a few more methods, that is a public void sample two. Okay, sample two. For this also I'll say system.out.println inside sample two method. Okay. I can implement that without any problem. Public void sample three. Some three methods I'll create for now. That will be more than enough. System.out.println inside sample three method. Okay. Three methods I have to create. Okay. Three methods I have created. Fine. First method, second method, third method. So there are three methods inside this class. I'll choose one of the method. I can choose any number of methods though. I'll choose one method. Let's say I'll choose this second method. Let's say sample two method. And I will try to put abstract modifier or abstract keyword before this method. The moment I added abstract modifier, I got a compiler error saying abstract methods do not specify a body. That means implementation is not possible. This selection part need to be removed because this method is now an abstract method. It cannot be implemented. It just need to be defined. It cannot have the method body. Put a semicolon here. Only the declaration part can be there. Again, I'm getting another compiler error. Why I'm getting another compiler error? When you hover the mouse, it will say that the class, if there is any Java class, if it contains some methods inside the class, this class contains some methods. In that methods, if at least one method is abstract specified method, then the class also need to be mentioned as abstract. Okay, hover the mouse, you will get the same message. Java compiler error saying the abstract method sample2 in type ABS demo is a class name. Okay, can only be defined by an abstract class. So if I mention abstract keyword for this class, then only the error will go away. Otherwise, error will stay. Okay. Two things will happen when you specify abstract modifier or keyword before a method. You have to remove the implementation of that method. Method cannot have the method body. Only the declaration of the method can be done. And the class containing at least one abstract method also need to be specified as abstract. Otherwise, the compiler error will another type of compiler error saying that the class which contains abstract method should also be abstract type will come. The moment I make the class also abstract, the error will go off. So hope guys, you got an idea or answer for this question. What happens when we specify abstract modifier before methods in Java? Two things will happen. That is, we cannot implement the methods or we cannot provide the method body. We can only declare the methods, abstract methods. Okay. And the class containing at least one abstract method also need to be specified as abstract. Okay. That's it. So that's all for this session. Thank you. Bye bye. Hello all. Welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what keyword is used to create objects in Java? Let me answer. In Java, in order to create objects, we have to use a keyword known as new keyword, N-E-W, new keyword. Okay. Using this keyword, we can create objects in Java. Let me first practically demonstrate how to use this new keyword in Java for creating objects in the Java programs. For that, I'll switch to this Eclipse IDE, and here I'll create a new class. I'll just name this class as a sample class. Okay, click on finish. And in this class, I'm going to create some sample variables and methods. For example, int a is equal to 10, and some method I'll create public void method 1. Okay, some sample class, sample variable, sample method. You can create any number of variables and methods inside this class, but I'm creating only one. So inside method 1, okay, like this I'll create one variable, one method for sample I created in the sample class. Now, if I have to create an object for this sample class, what I will do is I'll just create another class. Okay, I'll create another class. It will be looking good. I'll just name this class as demo class. Click on finish. Inside the demo class, I'm going to create a main method, etc. Okay, you can create any method. It may not be a main method. If it is a main method, you can run the code. Otherwise, you can also create a normal method. In the normal method also, you can create an object, no problem. Okay. But if the method is main method, I can run the code. So I created the main method. So fine, I'll show you. Normal method also I'll show you. Don't worry. Okay. So here I created one main method. Now this is a demo class and this is sample class. Now from the demo class, if I have to create an object for this sample class, which contains these variables and methods, I have to use a keyword known as new keyword. Okay, new keyword. Followed by this new keyword, I have to specify the name of the class for which I want to create the object. I want to create an object for the sample class, so I'll just give the name as sample. And after that, I have to provide the circular brackets and put a semicolon. This is how we can create an object for any class in Java. Here in this example, I created an object for the sample class with the help of the keyword. The answer for this question is, what keyword is used to create objects in Java? New keyword. Okay. So this is how the object is created. The moment you specify the class name after the new keyword, the object will be created, guys. And you have to end the statement like this. And so what happens here is, when I say new sample, in the, let's say, I'll explain more about this. Okay. Let's say this is the computer memory. Okay. Let's say this is the computer memory. In the computer memory, when I create an object for a class, okay, some memory will be reserved for that object. Okay. For example, this is the object. Okay. Object 1. Okay. Some memory. The moment you create an object, for example, if I don't initialize this variable, for example, a variable is there, some method is there. Okay. And now when I create an object for any class in the computer memory, some memory will be reserved for the object that got created. Okay. Now, how to refer to this object memory location? Because the memory address of this object will be in 10110011. We don't know. Okay. It can be in any combination. This kind of memory address, no one can remember. Like we cannot remember the phone numbers of all our friends, right? Or the contacts we have in our mobile phone, right? Similarly, this memory address of each and every object you cannot remember. So we have to give some name using which we can refer to this memory address, memory location or memory address. So that is called as object reference. So here in this statement, to refer to the memory location or address of the object of this particular class that we have created using the new keyword, we have to give some object reference. For example, I'll say S is equal to, okay, here S is the name of the object reference I have given. So using this object reference name S, it's like a name to this memory location or Okay, object memory location. Okay, using this is the object reference we call this one. We call it as object reference. Okay, using this object reference, we can refer because it's a name given to the memory location or address using which we can locate the memory address of the object that I have created. Okay, and here error is already coming. You see the error is coming because we have to declare this object reference with the same class type for which I have created the object. I have created the object for which class? Sample class. The same class name, I have to declare this object reference. So this is a complete object creation statement. Okay. Generally, whenever you see some people creating objects, they will write the statement like this. Now, using this object reference, what is the advantage? Just by creating object, it's not done, guys. Okay, if you give the object reference and declare that with the same class type for which object is created, now using this object reference, we can access the members of this class. I'll show you. So if I say s dot, you see, I can access the variable a using the object reference is equal to, I'll say 10. The system.out.println s dot a, I'll say. Okay, I can print the value of this 10. And similarly, if I want to call this method inside this class, for this class, I need to create an object. In order to create an object for the class, I have to use a new keyword. And once you create an object using the new keyword for this class, to refer to the memory location of this object that I have created, I have to give the object reference. I have to declare the object reference with the class type for which object is created. And using the object reference, I can call the, I can access the variable and initialize the variable with some value. Okay. And also I can access this method also. Okay. So to call the method, I have to say s dot method one. S dot method one. Okay. Like this also we can create. So this is the main method. I can run this code. You can see that the program will work fine. You see what happens is I created the object and assigned one value, and that value I'm printing. 10 will be printed in the output first. After that, when I call this method one in this sample class with the help of the object reference, inside method one will be printed. Okay, the method will be called and inside method one will be printed. You see 10 inside method one should be printed. 10 inside method one got printed. So this is a main method. In order to run the code, I have created the main method. In normal method also, you can do the same thing. Public void, okay, n method. I'm just giving some name like n method, normal method, let's assume. Here also you can create an object for the sample class. The method may not be a main method, guys. You can create objects for any other class in any methods, okay? Here also, you see, I can create an object. Same object I can create, okay? S is equal to or S1 is equal to, okay? Sample. Like this you can create, guys, no problem. This is the object reference now. And using the object reference, I can access the variable 20, okay? And s1 dot method also you can call, that is method one you can call, okay, from this class using the object reference, okay? But I cannot run this method. I have to call this method from this main method and then I have to run it. That's why I directly created the main method, guys. Either in main method or non-main method, you can create the objects. And the simple straightforward answer for this question, what keyword is used to create objects in Java, is new keyword. And the definition will be like this, okay? The syntax will be like this: new class name for which you need to create the object, and the class name should end with opening and closing circular brackets and semicolon. And once you create the object like this, to refer to this object, you have to give the object reference name, okay, some object reference name, and you have to declare that object reference with the same class name for which object got created. Okay, this is a complete object creation statement, and the new keyword is required for creating such kind of objects for any classes in Java. So with practical demonstration, I have answered this question for you. So that's all for this session. Thank you. Bye bye. Hello all. Welcome to this session. In this session, I am going to answer one of the Java interview questions. That is, what is the naming convention of variables in Java? Let me answer. Variables in Java need to be named using lower camel case naming convention. Whenever you are naming the variables in Java, you have to make sure that you are following lower camel case for naming them. So what exactly is lower camel case? Let me explain now. In order to understand lower camel case naming convention, you have to compare that lower camel case naming convention with the upper camel case naming convention. So let me write down here lower camel, okay, lower camel case naming convention this side, and upper camel case naming convention this side. Okay, when I compare this lower camel case with this upper camel case, right? So what will happen is you will understand the difference. Okay, if you understand the difference, you will exactly understand what exactly is the lower camel case. Okay, so I'll give an example for something. Okay, for naming something in lower camel case. If I have to name something in lower camel case, I have to write something like this. Okay, this is an example, guys, I'm giving. Okay, here while I'm naming something, okay, which need to be named in lower camel case, if there are 4 words, okay, in that name, if there are 4 words, the first word, you can see that first letter of the first word and remaining letters of the first word are in complete lowercase. Whereas second word onwards, the first letter of the second word onwards is uppercase. You see, third word, first letter is in uppercase. Fourth word, except first word, remaining all words, first letter will be in uppercase. Okay. Whereas first word will be in complete lowercase. Okay. Including the first letter. This is lower camel case. And for example, if I give an upper camel case example, like it is not like this, it is like this. Okay. The first words, first letter also is in uppercase. If you compare the lower camel case with upper camel case, here you see first word, first letter is in lowercase. But in upper camel case, from the first word itself, the first letter is in uppercase. You see, first words, first letter is in the uppercase. Second words, first letter is in uppercase. Third words, first letter is in uppercase. Fourth words, first letter is in uppercase. But in lower camel case, the first words, first letter is in lowercase. Remaining all words, first letter is in uppercase. Okay. So this is what is lower camel case. This is what is upper camel case. In order to name the variables and methods in Java, we use lower camel case. Okay, variables and methods in Java are named using the which naming convention? Lower camel case naming convention. But if you have to name classes, interfaces, okay, and project names, etc., those things need to be named in upper camel case. Okay, those things need to be named in upper camel case, whereas the variables and methods in Java will be named in lower camel case, where if there are multiple words while naming these variables and methods, the first word and it's including its first letter will be in lower case. From second word onwards, the first letter will be in upper case. That is lower camel case. Okay. So I'll practically demonstrate this one for you so that you will be able to understand the answer for this question in a better way. For that, I'll switch to this Eclipse ID and create a new class. I'll say variable naming demo, just giving some sample name, and with main method and all I'll create. That's okay. And inside that method, I'll just create a variable, guys. Okay, inside this method, I'll create a variable. Okay. I'll say string first name is equal to Arun. Okay. String last name. Okay. So just observe the naming convention I'm following for these variables. Okay. Here first name is a variable, last name is a variable. Okay. Otherwise, int car price is equal to 9 lakhs. Then double car mileage is equal to 24.12 and so on. Okay. And so on. I can create any number of variables and you can clearly observe the variables I have created so far here. They are in lower camel case. The first word will be in complete lowercase, including the first level. But from second word onwards, the first letter of the second word onwards, it will be in uppercase, third word, first letter, fourth word, first letter. If this variable name has multiple words, except first word, remaining all words, first letter will be in uppercase. Okay. So hope guys, you got the answer for this question with practical demonstration in this session. So that's all for this session. Thank you. Bye-bye.